December of 1941, when Japanese aeronautical engineers laid their hands on a captured Boeing B-17 Flying Fortress in the Philippines, they expected to find just another robust, but technologically inferior, American aircraft. What they discovered left them completely stunned. For the first time in the history of military aviation, a nation had managed to create a flying machine that functioned almost like a living organism, where each crew member moved in perfect harmony, guided by automated systems that seemed to anticipate their needs. The Japanese, masters of precision and industrial efficiency, found themselves facing a technological revolution that challenged everything they believed about aeronautical design. This discovery would not only change their perception of American industrial capability, but would force a complete reevaluation of their own engineering philosophies. What began as a simple technical analysis of a captured aircraft would transform into a journey of humility and admiration that would echo through the corridors of the Japanese aeronautical industry for decades. The Boeing B-17 Flying Fortress was not just a bomber, it was a declaration of American technological supremacy. With its imposing wingspan of 103 feet and 9 inches, this flying fortress carried 4 Wright R182-097 engines, each generating 1,200 horsepower. Capable of reaching speeds of 287 miles per hour and operating at altitudes of 35,600 feet, the B-17 represented the pinnacle of aeronautical engineering of its time. But the raw performance numbers were just the tip of the iceberg. The true secret of this machine lay in something much more subtle and revolutionary, something that Japanese engineers were about to discover dramatically. During the first months of the war in the Pacific, as Japanese forces rapidly advanced through the islands, capturing Allied territories and equipment, no one could have predicted that a single American aircraft would fundamentally change Japanese understanding of automation and operational efficiency. This discovery would come to haunt Japanese designers, forcing them to question decades of tradition in aeronautical design. The capture occurred during the chaos of the invasion of the Philippines, when Japanese forces found a virtually intact B-17 on an airfield hastily abandoned by American troops. What initially seemed to be just another war trophy would soon reveal itself as a window into a completely new technological world. Japanese aeronautical engineers, led by the renowned flight dynamics expert Hiroshi Nakamura, were immediately summoned to conduct a complete analysis of the aircraft. They arrived at the site with the typical confidence of a nation that had dominated the Pacific seas in the early months of the war, expecting to find a typical American machine, robust but unsophisticated. What they found, however, challenged all their expectations. From the first moment they entered the cockpit, something seemed different. The controls, the instruments, the layout of everything, it all seemed to flow in a way they had never experienced in their own aircraft. It was as if the machine had been designed not just to fly, but to think along with its crew. The first shock came when Japanese engineers discovered Honeywell's C-1 autopilot system. This was not just a simple stabilization device, but an electronic brain capable of maintaining altitude, heading, and speed without constant human intervention. While Japanese aircraft relied entirely on the continuous skill and concentration of pilots, the B-17 allowed its crew to focus on other critical tasks during long flights. Nakamura was fascinated to discover that the system could automatically compensate for weight changes as bombs were dropped, adjusting the aircraft's trim without the pilot needing to make manual corrections. But this was just the beginning. The Norden bombsight proved to be a masterpiece of mechanical and optical precision, capable of automatically calculating ballistic trajectories considering altitude, wind speed, and aircraft movement. Japanese bombardiers, however skilled they might be, relied primarily on visual estimates and personal experience. Here was a machine that transformed bombing from art into exact science. The most disturbing revelation, however, was yet to come. As time and motion studies progressed, Japanese engineers began to realize that every aspect of the B-17 had been designed with crew automation in mind. The internal communication system allowed instantaneous coordination among all crew members, while artillery controls were positioned so that gunners could operate multiple 50-caliber machine guns with maximum efficiency. The automated hydraulic system controlled landing gear, flaps, and other control surfaces with precision that surpassed anything the Japanese had developed. Even more impressive was the automated oxygen system, which adjusted flow based on altitude, ensuring the crew remained alert and efficient even on prolonged high-altitude flights. Each discovery was a lesson in humility for engineers who considered themselves among the best in the world. They began to realize that they were not just analyzing an aircraft, but studying a completely different design philosophy, where machine and man worked in perfect symbiosis. This perception began to shake the foundations of everything they believed about aeronautical engineering. The comparison with Japanese aircraft became inevitable and painful. The Mitsubishi A6M0, the pride of Japanese naval aviation, was a masterpiece of simplicity and agility, but it relied entirely on the exceptional skill of its pilots. There was no autopilot, automated aiming systems, or any form of electronic assistance. The Japanese pilot was, essentially, the sole brain of the aircraft, responsible for every decision and adjustment during flight. This philosophy had worked magnificently in the early months of the war, when highly trained pilots dominated the skies. But engineers now realized the inherent limitations of this approach. Pilots grew tired, made mistakes under stress, and their skills varied drastically. The B-17, on the other hand, elevated the average crew performance through automation, allowing even less experienced crews to operate with remarkable efficiency. The Nakajima B-5N bomber, Japan's primary attack aircraft, seemed primitive in comparison. Its bombardiers relied on manual calculations and visual estimates, while the B-17 offered automated precision that transformed every mission into an exercise in scientific efficiency. The realization was devastating. The Americans had not only built better aircraft, they had completely reimagined the concept of military aviation. Internal reports by Japanese engineers, discovered decades later in military archives, reveal the depth of their astonishment and admiration. Nakamura wrote in his personal diary, "We are not just facing superior machines, but a completely different mindset about what it means to fly in combat." Time and motion studies showed that a B-17 crew could execute complex bombing sequences with chronological precision, while equivalent Japanese crews spent precious time on manual calculations and constant adjustments. Automation not only improved efficiency but drastically reduced crew fatigue, allowing for longer and more precise missions. Engineers were particularly impressed with the centralized fire control system, which allowed the aircraft commander to coordinate all defensive weapons from a central position. In contrast, Japanese aircraft relied on verbal and visual coordination between individual gunners, a system prone to confusion and inefficiency during intense combat. Each new discovery deepened the perception that they were facing a technological revolution that had gone unnoticed by Japanese military intelligence. The war in the Pacific was not just a matter of courage and individual skill, but of systemic superiority and intelligent automation. Analysis of the B-17's navigation systems revealed another level of sophistication that left Japanese engineers perplexed. The American bomber possessed radio navigation equipment that allowed precise navigation even in zero-visibility conditions, something unthinkable for Japanese aviation at the time. The primitive radar system, though still under development, showed the potential for target detection and automated navigation that would completely transform the nature of aerial warfare. The Japanese realized they were witnessing the birth of a new era in aviation, where electronics and automation would gradually replace exclusive reliance on human skill. The automated cabin heating system ensured the crew remained operational even at extreme altitudes, while Japanese aircraft relied on personal protective equipment that limited crew mobility and efficiency. Every system seemed to have been designed not just to function, but to function integrally with all other systems, creating a synergy that multiplied the aircraft's overall effectiveness. This holistic approach to aeronautical design was completely alien to the Japanese mindset, which traditionally focused on optimizing individual components. The growing perception was that the Americans had developed not only superior technology, but a fundamentally different and more advanced engineering philosophy. The moment of greatest impact came when the engineers test flew the B-17 in a simulated flight, operating all systems as designed. The experience was transformative. Nakamura, an experienced pilot as well as an engineer, later reported that flying the B-17 was like dancing with a machine that anticipated every move. The autopilot kept the aircraft stable while he focused on navigation and communication. The bombsight automatically calculated the necessary corrections for precise bombing. The hydraulic controls responded with a smoothness that made complex maneuvers almost effortless. For the first time, the Japanese experienced what it meant to fly a truly automated aircraft, where the machine amplified human capabilities instead of simply obeying commands. The Japanese crew who participated in the tests were impressed by the dramatic reduction in fatigue and stress during prolonged operations. They realized they could maintain concentration and precision for much longer periods than in their own aircraft. This practical experience confirmed all theoretical analyses. The B-17 was not just a better aircraft. It was a demonstration of a completely new approach to military aviation. Automation did not replace human skill, but elevated it to previously impossible levels. The strategic implications of this discovery began to haunt the Japanese military command. If the Americans possessed hundreds, perhaps thousands, of aircraft with this level of automation and efficiency, Japanese air superiority was fundamentally threatened. It was not just about numbers or raw speed, but a systemic advantage that allowed the Americans to extract maximum performance from crews with relatively less training. The Japanese realized that their strategy of relying on highly trained elite pilots had inherent limitations. These pilots were irreplaceable, and once lost, took years to replace. The B-17, on the other hand, democratized excellence through automation, allowing average crews to achieve exceptional results. This perception forced a complete reevaluation of Japanese air doctrine. Engineers' reports recommended immediate investment in research and development of automated systems, but the Japanese industrial reality made this extremely difficult. The country simply did not possess the electronic industrial base necessary to quickly replicate American advances. The war had become not just a military conflict, but a technological race where Japan was dangerously behind. The B-17's automation represented years, perhaps decades, of development that the Japanese would have to compress into months to remain competitive. The legacy of this discovery echoed far beyond the end of World War II. The Japanese engineers who studied the captured B-17 became pioneers in the development of Japan's post-war aeronautical industry, applying the lessons learned about automation and system integration. Companies like Mitsubishi Heavy Industries and Kawasaki incorporated automated design principles into their civilian and military projects in the following decades. The experience with the B-17 also influenced the development of the Japanese electronics industry, which would eventually become a world leader in automation and robotics. Nakamura, in his memoirs published in the 60s, wrote, "That B-17 taught us that the future belonged not to those who built faster or stronger machines, but to those who managed to make machines and humans work as one organism." This philosophy would become fundamental to Japan's post-war industrial rebirth. The historical irony is palpable. An American aircraft captured during the war provided the intellectual seeds for the Japanese technological revolution that would dominate the following decades. The automation that the Japanese discovered in the B-17 would eventually evolve into the robotic and automated manufacturing systems that would make Japan a global industrial power. The American bomber had planted the seeds of its own obsolescence, inspiring advances that would completely transform the nature of military and civilian technology. The story of the captured B-17, studied by Japanese engineers, represents more than a fascinating episode of World War II. It illustrates how true innovation transcends national and ideological boundaries. The crew automation that so impressed the Japanese became the standard for all modern aviation, from supersonic fighters to commercial aircraft. Today, when we step into any airplane, we experience the direct descendants of the systems that left those Japanese engineers so perplexed in 1942. The autopilot, integrated navigation systems, flight control automation, all these elements trace their lineage back to that flying fortress that forever changed Japanese perception of what was possible in aviation. The deepest lesson of this story is not about American technological superiority or Japanese inadequacy, but about the transformative nature of true innovation. When Japanese engineers admitted the superiority of the B-17's automation, they were not just acknowledging superior technology, but embracing a new philosophy that would eventually lead them to create some of the world's most advanced technologies. The American bomber had inadvertently become the teacher who would inspire its own successors.